Good morning, students. Let's begin with our next chapter of the unit Modern Physics, that is Atomic Physics. So, we are going to discuss here the physics which is dealing with the atom, means what is the structure of atom and what are the various formulas for the velocity of the electron, for the radius of the atom, and many more. So first of all, let us understand what do we mean by Dalton's atomic theory. So, what is Dalton's atomic theory? Which says that every element, or we can say every matter in the universe are made up of atoms. But here the atoms which are there of the same elements are exactly same, and atoms of different elements are different. This is Dalton's atomic theory. Now let's discuss the Thompson's atomic model. Thompson said that the atom has the positively charged sphere is a positively charged sphere, and he said that the radius of atom is 10 to the power minus 10 meter. Also, the electrons are distributed uniformly, just like in the pudding we see the plum are distributed uniformly. Similarly, over here in the atom, the electrons are distributed in the similar manner. Now, what were the limitations of the atomic model by the Thompsons? So we have to discuss the limitations. That what are the major limitations of the Thompson's atomic model? So first was that the spectral series which we study were not explained and observed by Thomson. Second was that the alpha particles which were scattered, as we have already studied in the Rutherford's model in our earlier classes, how that alpha particles scattered. So these two were the main the drawbacks of the Thomson's model of atom. We already know what is the Rutherford's model of atom, but here I would like to give you some key points related to the Rutherford model of atom. Take the help of these words and try to remember what was Rutherford's atomic model. First is the radioactive source. Second is thin gold foil. You might also know that why Rutherford chose gold foil. Third, zinc sulfide screen detector plate or detector screen. And after the key points, we also know the conclusions. That what were the conclusions for this Rutherford model of atom? So Rutherford made what conclusions? First of all, that the atom, when we talk about the atom, so the atom is of 10 to the power minus 10, but for nucleus the range is 10 to the power minus 15. So you can see that if nucleus is 1 meter broader, then the atom will be this much meter more than the nucleus. So we can say that this was the distinction that was made. These were the observations. Also, we also know that the conclusion, one of the conclusion, that is the revolution of the electrons around the atom. This was another important conclusion, and after that some extra conclusions that we are going to discuss here. Let us start studying those conclusions. So important conclusions on that, we also know that the total positive charge is stabilized by the total negative charge. Okay, and for the electron revolution, so that the electron does not go out of the atom, there is one centripetal force provided. There is one centripetal force which is provided by nucleus, which will attract towards the center. Means whenever the electron is revolving, it will always be attracted towards the center. Now let us discuss the another important topic, that is the distance of closest approach. Let's learn what do we mean by the distance of closest approach or the closest approach distance. First of all, we should learn that it is denoted by R0. Now what is it actually? So suppose we are having the alpha particle and this is our atom and it is the nucleus. Now you know that the nucleus will exhibit the repulsive force to a positively charged body. Why so? Because the nucleus is itself a positive body. This alpha particle is very less charge and very less mass as compared to nucleus. So if it will move near to nucleus, so it will continue to move until and unless some point will come where this particle will be having here maximum potential energy which is due to the nucleus, and it will have here the least kinetic energy. Now after that, this particle will reverse its direction. Either it will go here or it will go here, or it will trace its path back, or it will deviate here, whatever, but it cannot now no more it will follow the distance which is closer to the nucleus. It will try to repel itself from the nucleus. That is known as the closest approach distance. So what is the formula for closest approach distance? So the formula is R0 is denoted by 1 upon 4 pi epsilon naught. We know epsilon naught is the permittivity of the free space. After that there is 2z. Z is the charge of the nucleus and E is the charge of the electron and its square. Then after that multiply by kinetic energy. So this is your distance of the closest approach formula, and you have to learn this formula by heart. Impact parameter. So what do we mean by impact parameter? Suppose this is our nucleus, suppose this is our atom and it is the nucleus and it is the nucleus line. Now we know that this nucleus line, whatever alpha particle will be going, will have the maximum of the will follow or will trace its path back when it will reach near to the nucleus. If I have an alpha particle over here moving over here in this direction, so the direction of this alpha particle will be like this. Okay. Now what do you mean by impact parameter? So it is the distance between this line, means the alpha particle path line, and the nucleus line. So the distance between these two is the impact parameter. It should be provided that the nucleus line, that is NL, should be parallel to the path line by alpha particle. Okay, so path line which is traced by alpha particle. So this is known as impact parameter. This impact parameter is denoted by B, and when we talk about what is the formula of this impact parameter, so we get that impact parameter B will be equal to 1 upon 4 pi epsilon naught Z E square cot theta by 2 upon kinetic energy. Now here you know this Z is the charge of the this Z is actually the charge of the nucleus, and after that we know that what is this E? This E is actually the same that we have already discussed, which is the charge on the alpha particle. This value cot theta by 2 has been put in the formula, and after that we also have the kinetic energy. This kinetic energy is of alpha particle. So this is the definition of the this is the formula of the impact parameter. You have to also learn that this theta which we have put over here, this theta is actually the angle of scattering. Means when this is the nucleus and this is the nucleus line and this is the alpha particle which comes, it deviates over here. It should follow this path, but because of the nucleus it has got deviated. So this is our theta and this is only this angle of scattering. When we talk about the Rutherford scattering formula for the same, we have n theta. N theta is the number of alpha particles is equals to Ni. Ni is the total number of alpha particles which reach the screen multiplied by n. This n is the number of atoms which is in per unit volume, means in one volume equal to 1 liter, how many atoms are there, in 1 meter cube how many atoms are present. After that, this is z square. Z, you know, z is again the atomic number over here, and E is the charge on alpha particle to the power 4, and after that upon 8 pi epsilon naught whole square. This r is small r, and then E square sine 4 theta by 2. So this is the Rutherford scattering formula. You do not have to learn this formula, you have to learn one proportionality. Proportionality is n will be inversely proportional to sine 4 theta by 2. Now you again know what is the n. N is here the number of alpha particles. Now you should know that greater is this angle of scattering, which is a theta, the less is the number of alpha particles. Means you can know that most of the alpha particles are passing like directly. If we are having this atom, so nucleus is so small that most of the alpha particles are scattering, and some of them are scattering at lower angles. But if we talk about the greater angle, means some of them are moving like this or some of them like this. So this is actually less. These number is less because nucleus is very small. Now let's discuss what are the limitations of Rutherford's model. So here I am giving you some hints, some words which you can take as a hint to know that what could be the points. So the first limitation in that I am giving you the hint as the stability. And the second hint is about the line spectrum. So these are the two hints which I would like to give you, and you can probably conclude out your conclusions. What can you conclude from the two hints which I have provided? For the stability, we know that when the electron is moving, so according to the Maxwell equation, the electron when it is moving, it should emit out electromagnetic wave, or it should emit out electromagnetic radiations, and ultimately it should lose the energy. And when it is losing the energy in the form of electromagnetic radiations, it should fall in the nucleus. For this, the Rutherford could not give any possible explanation that why the electron does not fall inside the nucleus. The second hint that we can draw out was about the line spectrum. So as I already told you that when the electron is emitting out the electromagnetic radiations, so when it is absorbing the energy, then there should be some line spectrum that we should absorb because it is moving to higher level. So there should be some line spectrum, but there is no such proof in the Rutherford atomic model that what is the explanation for the line spectrum which we observe in the hydrogen atom. So to overcome this all, we have Bohr's atomic model, which explains that whatever were the limitations that were there in the Rutherford's atomic model are all overcome by Bohr's atomic model. So now let us start with that. So now let us talk about Bohr's atomic model. So Bohr's atomic model is actually given in the form of postulates. Means there are some of the important postulates that you have to learn when we talk about the Bohr's atomic model. So what were those postulates? So let us talk about them. So the first postulate was that always the electrons will always revolve in certain non-radiating. Now what is the meaning of non-radiating? Which do not emit any electromagnetic radiation, non-radiating orbitals or shells or orbits, but these orbits, there is one condition, that these should be at least integral multiple of h upon 2 pi, and this is its angular momentum. Means angular momentum should be integral multiple of h upon 2 pi. Means L should be equal to nh upon 2 pi. When we talk about the nth orbit, L can be written as mvr equal to nh upon 2 pi. So this is your final equation which is being framed. You should know that this n is integer, means neither it can be negative, it cannot be possible, it cannot be possible as a decimal, and it cannot be possible as a fraction also. It should only be in the form of positive integer. Also, Rutherford said that the orbits can be 1, 2, 3 till infinite, but always should be an integer which is positive. Now, the electromagnetic radiations, electrons generally do not emit out, except the electromagnetic radiations will be emitted when the electron jumps from, suppose, first orbit to fourth orbit. So here the electromagnetic radiations will be emitted out. So this is important, and the electromagnetic radiations are of the magnitude h nu equal to E2 minus E1. This E2 is the energy of the new orbit where the electron has reached, and E1 is the energy of the old orbital where the electron was earlier present. So we can write h nu equal to E2 minus E1. When we talk about the radius, suppose electron is present in the nth shell. Now what is the radius of that nth shell? So you have to write r equal to n square h square upon 4 pi square m k z e square. This is the formula for the radius. You know every value. This is the orbit, this is Planck's constant, 4 pi are the constants, mass is mass of electron, z is the atomic number, e is the charge of electron. When we put the values of all the constant, we get r equal to 0.53 multiplied by n square upon z angstrom. This is the value which you have to learn. Suppose, let us do one question first to understand it better. Now the question says that we have an electron, and electron is present in the 7th orbit. Now we have to calculate the radius of that, and this is actually a hydrogen atom. So for this, what will be the formula that we have to apply? We have to put r equal to 0.53 multiplied by n square upon z angstrom. So now how will we solve? Radius equal to 0.53 multiplied by, now this n is 7, so 7 multiplied by 7 because it is square is there, upon z. For hydrogen atom, z value is 1 angstrom. So when we calculate it, it is 0.53 multiplied by 47. So the radius of the hydrogen atom is 0.53 multiplied by 47, which gave us 24.91 angstrom, which we can write as 24.91 into 10 to the power minus 10 angstrom.